Hi, I am TS Sir, your favorite physics teacher, a teacher not by chance but by choice. I welcome you all to another session on concepts, misconceptions, and mistakes in physics. So, this is one of the popular misconceptions among students. They don't know when does friction act and when does friction not act. How to know whether in a particular situation friction will act or friction will not act. What will be the magnitude of the friction and what will be the direction of the friction. So today, now I am going to discuss these three cases: whether friction will act or not, what will be the magnitude of friction, and what will be the direction of the friction. So try to remember this. Friction acts when these conditions are satisfied. So friction acts when the surfaces are in contact and the surfaces should be rough. This is my first point. This everyone understands. The confusion comes when we don't check the second condition. So the second condition is there should be either relative motion or tendency for relative motion between the points of contact. I am repeating it again. I am repeating it. So friction acts if the surfaces are in contact and they are rough, and second, if there is relative motion between the points of contact or tendency for relative motion between the points of contact. So what does that mean? Let's take one by one example, one by one cases, and understand it. So generally, students don't pay attention to these three terms. They generally think friction has something to do with motion. But be careful, friction doesn't have to do anything with motion, it has to do something with relative motion. So we start thinking in terms of motion, therefore we make mistake in friction. So instead of thinking in terms of motion, let's think in terms of relative motion. So it acts if there is relative motion. If there is no relative motion, then go to the next option. Is there a tendency for relative motion? Look at the word tendency very carefully. Tendency means in Hindi forces. Is there any force which is trying to slide one body over the other, which is trying to make the two surfaces move against each other? So before understanding friction, you should be uh, expert in drawing the free body diagrams and finding out what are the forces acting and in which direction. Looking at those forces, if you find that there is some force which is trying to produce relative motion, trying to slide one body past the other body, then friction will act, right? And the third point which I would like to draw your attention is between points of contact. So it is about relative motion, not about motion. Second, if there is no relative motion, then try to look for tendency for relative motion. Third, don't try to look for relative motion or tendency for relative motion between any two points or between the centers of the bodies. Try to see if there is relative motion or tendency for relative motion between points of contact, the two bodies. Let's say they are in contact. So the bottom surface of the top body and the top surface of the bottom body. Try to see what is happening between those two surfaces. Is there relative motion between those two surfaces? Don't try to see what is happening to the center of mass or what is happening to the center of the body, right? This point, it will be very useful while studying about rolling. Okay, so let's not remember about rolling now, and let's continue these 6 cases which I have shown here. So I will try to apply these points one by one. Okay, case 1. So here you see in case 1, you have a block on ground, the ground is at rest and the body is also at rest. The friction coefficient between them is mu. That means the surfaces are rough. When I am writing here mu, that means the surfaces are rough. So will there be friction acting here? Let's check. First, is there relative motion? No, there is no relative motion. Body is red, body is at rest, and the ground is also at rest. Second, is there tendency for relative motion? Try to draw the free body diagram. So here you find that M is acting vertically downward on the block and normal reaction is acting vertically upward on the block. Is there any horizontal force which is trying to slide the body over the ground? on the ground? No. So there is not even tendency for relative motion. Of points of contact, of course I am talking about the point of contact only, the two surfaces which are in contact. So there is neither relative motion nor a tendency for relative motion. So there is no friction here. So there is no friction acting here. Okay, come to case 2. Come to case 2. Here you see again a force F is acting but the body is at rest. Mass of the body is m and the friction coefficient is mu. Is friction acting here? Let's check the points. Let's see whether the conditions are satisfied. First point, is there any relative motion? No, the body is at rest and the ground is also at rest. So there is no relative motion. Second, is there any tendency for relative motion? Try to draw the free body diagram of the block M. You see here there is a force mg in this direction, normal reaction in this direction and F in this direction. So yes, there is tendency for relative motion. This F is trying to slide the body on the ground. So there is tendency for relative motion. Someone is trying to slide. There is no relative motion, that's another thing, but there is a tendency. So friction is acting here. So in case 2, friction is acting. Come to case 3. Will friction be acting here? Let's check the conditions. Are the surfaces in contact and rough? Yes. Is there relative motion? Yes. The body is moving with some speed and the ground is at rest. So there is relative motion. So will friction be acting here? Yes. This condition is satisfied. There is relative motion. I don't have to check this one. I don't have to check this one. There is relative motion. That means friction is acting. If not, then I will go to check this one, isn't it? ये दोनों में से कोई भी एक satisfy होगा तो friction तो लग ही जाएगा. So here also friction is acting. Okay. Come to case 4. Will there be friction? Will friction be acting here? Here, first. Is there relative motion? Is there relative motion? No, because the body is also moving with speed u and the belt on which it is kept is also moving with the same velocity. Both have same speed, same direction, so they have same velocity. So there is no relative motion. Acha, is there any tendency for relative motion? Now I am going to check the second one. Is there tendency for relative motion? No, there is not even tendency for relative motion. If you draw the free body diagram of the masses, it is mg in this direction, normal is in this direction, they are in the vertical direction only. There is no horizontal force which is trying to slide either the belt or the mass one on the other. So there is no friction. Achha, coming to case 5. Will friction be acting here? Let's check. The body is at rest, the plank is moving. The conveyor belt on which it is kept, it is moving. So is there relative motion? Yes. So there is relative motion. So friction is acting here. Okay, now here, is friction acting here? Let's check. Look at the 2 kg block. Look at the 2 kg block. It's moving with 1 meter per second, and the other block on whom it is kept is moving with 3 meter per second. So is there relative motion? Yes, there is relative motion. So friction is acting on the 2 kg block. So friction is acting on the 2 kg block. Does friction act on 4 kg block? Yes. You see the 4 kg block is moving with some speed, so it is having relative motion with respect to ground as well as with respect to the 2 kg block. So the surfaces of 4 kg block, it is in contact with others and it is having relative motion. So friction is acting at this surface as well as at the surface of the 4 kg block. That means friction is acting in case 2, in case 3, in case 5 and in case 6. Now the misconception. Many times students think that if the body is at rest, then friction shouldn't act on it. And if the body is moving, then friction should be acting on it. It's not like that. Friction is not related directly to rest or motion. It is related with relative rest and relative motion. You shouldn't look at rest and motion. If you try to look in that way, then you will be confused. For example, here you see, this is case 1, body is at rest, no friction acting. Case 2, body is at rest, but friction acting. That means the body may be at rest, friction may be acting, friction may be acting, friction may not be acting. Now, look at case 3 and case 4. In both these cases, bodies are moving. But you see, in case 3, friction is acting, and in case 4, friction is not acting. So the body may be moving, and even when the body is moving, friction may act, may not act. The body may be at rest, And even though the body is at rest, friction may act, friction may not act. So rest does not imply no friction, and motion doesn't imply friction. This is a misconception. So friction is not related to rest or motion per se. It is related to relative rest and relative motion between the points of contact. Now, friction is of two types. So till now I have explained you whether friction acts or not. How to understand in a particular situation whether friction acts or not. Now I am going forward to identify the kind of friction acting. So friction is of two types. One is called as static friction and the other is called as kinetic friction. Once you identify what kind of friction is acting, then only you will be able to write down the magnitude and direction. Therefore, we need to separate both the cases, both the types of friction. One is static friction and the other is kinetic friction. Coming here. So what we have found, friction acts when there is relative motion or tendency for relative motion. Now, if friction is acting because of relative motion, that's kinetic friction. And if friction is acting because of tendency for relative motion, that is static friction. I am repeating. So if friction is acting because of relative motion, then it is kinetic friction. Then it is kinetic friction. And if friction is acting because of tendency for relative motion, then it is static friction. Then it is static friction. So the video is going to get longer, so let me stop here. More about the magnitude and direction of friction we will talk in the next video. If you feel that this video has helped you, don't just keep this with you. Try to help your neighbors and friends by sharing this video to them. Thank you.